Hey everyone, Mr. Newman here, and today we're going to learn about factoring polynomials. First of all, we got to remember what factoring means. The factors of 15 are 1, 5, 3, and 15. The reason for that is because those are all the numbers that multiply to get you the original number. 1 times 15 is 15, and 3 times 5 is 15. So, let's look at when we have a variable. What are the factors of 4x? Well, 1 is a factor. 4x is a factor because 1 times 4x equals 4x. But there are other factors. We could also say 2 is a factor, and 2 times what equals 4x? Well, that'd be 2x. So 2 and 2x are both factors because you can multiply them to get 4x. 4 and x are also factors. Notice how 4 is different than 4x. So, what are the factors of 3x squared? Well, 1 is a factor, and 3x squared is a factor because you can multiply those two together to get 3x squared. Also, 3 and x squared multiply together to get 3x squared. Also, 3x and x also multiply together to get 3x squared. Now, this last one is a little bit trickier because you have 1 and 5ab squared. You also have 5 and ab squared. You have 5a and b squared. You have 5ab times b because 5ab times b gives you 5ab squared. But there's also a few others that if you were careless you might miss. For example, 5b is a factor we haven't listed yet. And what do you multiply 5b with to get 5ab squared? Well, ab, because 5 times b times a times b is 5ab squared. Also, 5b squared is a factor, and to get 5ab squared, you multiply that by a. So notice all of these, the key important thing, I don't care quite so much that you can find all the factors, I care much more that you recognize that they are factors. So if I say, is this a factor? You go, yes, that is a factor, because it multiplies with something else to get the original number. Now, what if I had a binomial, 3x plus 9? Well, what can I multiply to get 3x plus 9? What you have to think of is you have to remember the distributive property. Okay, so factoring binomials works a little bit different than the monomials we did up above. What if I did 3 times, in parentheses, x plus 3? Well, let's distribute that and multiply that out and see what we get. When you distribute the 3, you get 3x plus 9. Isn't that what I just asked? What are the factors of 3x plus 9? Well, so that means that 3 and x plus 3 are factors of 3x plus 9. Let's try this with 2x plus 8. What can be multiplied by and go into 2x and go into 8? Well, 2. So 2 times x plus 4 multiplies together to get 2x plus 8. So 2 times x plus 4 must be a factor of 2x plus 8. Now notice for each of these, I'm checking my work by distributing it back out and making sure I get the original equation. That's what we're going to have to do down here in a little bit. Go ahead and try to factor 6x plus 9 on your own. All right, did you get it? So you have 3 goes into 6x and 9. And what is going to be in parentheses? Well, 2x, because 3 times 2x is 6x, and 3. So notice when you multiply that out, you get 6x plus 9. So 3 and 2x plus 3 are factors of 6x plus 9. Factor 4x plus 8. All right, did you get it? Well, you might have seen, or a lot of you probably tried to do 2, and that does work because 2 goes into 4x and 2 goes into 8. You get 2x plus 4. But some of other people in the class might have done 4 times x plus 2. Because when you distribute that, you also get 4x plus 8. So which is it? Well, they are equal, but there's something important going on here. When I ask you to factor a binomial, we need to fully factor it. If you look down here, 4 times x plus 2 is fully factored because we've taken out as much of a factor as possible. If I ask you to simplify something, that's when we distribute stuff. So on one side of things is fully factoring things. On the other side of these kinds of problems are simplifying. Notice how 4x plus 8 is the simplified version. This 4 times x plus 2, if I ask you to factor something, that means to fully factor it. So the only correct answer is 4 times x plus 2. This 2 times parentheses x, 2x plus 4 is not enough of a factoring. And you could see that because you notice inside of here, we still have a 2 that could be taken out of there and a 2 that could be taken out of there. And when you take that other 2 out, you get 2 times 2 on the outside, which is 4. So this number 4 is called the greatest common factor. That's really important to know because it's the largest number that is common, in other words, that both of them have, that you can factor out of 4x and 8. Okay? We abbreviate this with GCF, and what we're going to do from here on out is look for the GCF first, then factor it. So let's get started. We have a lot of these problems to do. This first one, 5x plus 10, the GCF is 5. So I'm going to write 5 out in front and put a parentheses. When I take a 5 out, we're left with an x, and then we're left with a 2, so x plus 2. To check these problems, we just need to distribute them back out. So you distribute the 5, you get 5x plus 10, which is my original expression, so that is correct. The next one, the GCF is 2. So I'm going to write down a 2, and then after, in parentheses, I'm going to write what do you get when you divide out or take out the 2. Well, what's left over? There's 2x, and then there's a 5. So let's check and make sure we got it all correct. 2 times 2x plus 5, distribute it, you get 4x plus 10, so we were correct. 2 times 2x plus 5 is the factor. For the next one, this is a little trickier because we have x's on both terms. So you can take out a 5, but you can also take out an x. So let's write down 5x and see what happens. When you take 5x out of 5x squared, you're left just with 1x. And on the right side, you're left with a 3 when you take 5x out of 15x. If you're wondering how I got those, let's distribute it and look at see what happens. So I distribute the 5x. 5x times x is x squared. Aha. And 5x times 3 is 15x. That was my original expression, so this is the factored form. Next, 5a is the greatest common factor between 35a and 10a squared. When I write that, I need to write 5a, then parentheses. When I take out of 5a from 35a, I get 7. When I take out of 5a from 10a squared, I get 2a. And let's check. Yes, it does give me 35a, and it gives me 10a squared, so this is the correct factored form. For the next one, 2x is the greatest common factor, so write down 2x. I'm left with a 4 and a 5y. Let's check and make sure when you multiply that back out, you get 8x plus 10xy, so that is correct. On the next one, we have two variables that we can factor out because there's an m and an n on both terms. So the greatest common factor is 2mn. Notice that when I do that, I don't put m squared because there's no m squared on the second term. So the greatest common factor is only 2mn. When we take out 2mn from 12m squared n, we're left with 6m. And on the right side, we're left with just a 5. Notice when I distribute this back out, I get my m times m, so that's m squared, 12m squared n. And on the right side, we get 10mn. Down here, it gets a little trickier with the powers. 10gh squared is the greatest common factor. And notice the greatest common factor, whenever you have multiple variables, it's always, if the variable is in both spots, it's the smaller of the two powers. So see how there's g squared and g to the first? G to the first is the greatest common factor. There's h to the third power and h squared. Well, that means h squared is the greatest common factor. You'll see why when you multiply it back out. So I'm left with an h in the first term and a 2g in the second term. Let's multiply that out and make sure. So 10gh squared gives me 10gh cubed, which is what I wanted, plus 20g squared h squared. So that is the correct answer. This last one here we're going to do, 4ab squared c. Notice again, I took the smallest power between each one. So there's a cubed and a. That means a is the smallest power. Both of them have b squared, so I can write a b squared there. Now, to figure out what's left over, you just have to divide that out. So 4ab squared c, when you divide 36a cubed b squared c, divide that by what we took out, you're left with 9a squared. When you divide it out from 16, you get 4c squared. Multiply that back out. Notice that you get 36a cubed b squared c and 16ab squared c cubed, so this is the correct factor. All right, we got to go a little faster because we have a fair bit more yet to do. So now we're factoring trinomials. Before we get to that, I want you to multiply the x plus 1 times x plus 3. All right, did that. We've done that enough, so you guys should be able to get that. It's x squared plus 4x plus 3. So if I asked what are the factors of x squared plus 4x plus 3, well, you know that x plus 1 times x plus 3 multiplies to get x squared plus 4x plus 3. So those are the factors. That's great if I tell you what the answer is, but how do we figure that out? Well, this is standard form here. Notice ax squared plus bx plus c. When a is 1, that means we just start with x squared at the front. The rest of this worksheet, we're just going to be dealing with a as being 1. What we are allowed to ask is we can ask what two numbers can sum, in other words, what can add to get b, and what can multiply to get c. So let me show you the steps of how to do this. Whoops. Multiply. There we go. List the factors of c will be the first step. Then you want to figure out which of those add to b, and then you're going to write it out as x plus the first one and x plus the second one. Let's test that out. So, what is c? C is always the last term when it's written in standard form. It's the term without any x's on it. So factors of c here, well, 2, the only numbers that multiply to get you 2 are 1 and 2. Notice that they add up to 3, and that's what we want because that's our b right there. So what we're going to do is we're going to write x plus blank and x plus blank, and I'm going to fill that in with 1 and 2. And you could check this. I don't have time in this video to do that now, but you could check this by multiplying it back out with a box. Once you do that, you'll see you will get the original equation, x squared plus 3x plus 2. All right, let's go to the next one. Here we've got, so that is the correct answer. We want the factors of 6. That's our c. So the factors of c are 1 and 6 and 2 and 3. Notice I don't also need to write down 3 and 2 because that's the same as 2 and 3. When we add these together, we get 5 and we get 7. Well, we want the one that adds up to 7. So I'm going to circle 1 and 6. So x plus 1 and x plus 6 is the factor, is the factored form. Here for this next one, go ahead and list the factors of 8. Did you get 1 and 8 and 2 and 4? Well, we want the ones that add to 6. That's going to be 2 and 4. So x plus 2 and x plus 4, and we have factored that trinomial. All right, well, what if c is negative? Well, notice here we have negative 2. What multiplies to get negative 2? Well, there's 1 and negative 2, or negative 1 and positive 2. So you have to be aware of both of those sets of factors. Notice there's a nice symmetry to it, though, so you can always switch which one's negative and figure them both out. These add up to negative 1, and the second set add up to 1. Well, what do we want? Well, remember, when there's nothing in front of the x, there's an invisible 1. And that's going to be positive because it's plus 1. So we want this one. So we write down x minus 1 because of the negative 1 and x plus 2. And that is the factor of that trinomial. Try this next one. We want to write down 1 and negative 6, negative 1 and 6. But there's also 2 and negative 3 and negative 2 and 3. Well, which of these add up to negative 5? Be very careful. They are 1 and negative 6. So those are going to be our factors, x plus 1 and x minus 6. For this third one, we want to add up to multiply, find the factors of negative 12. That's going to be 1 and negative 12, negative 1 and 12, 2 and negative 6, negative 2 and 6, 3 and negative 4, and negative 3 and 4. Phew, well, which of those add up to negative 1? That would be 3 and negative 4. Now you could write down the sum of all of these just to check, but I did those and just found that these are the only ones that add up to negative 1. So x plus 3 times x minus 4 are our factors. Next one's here. What if b is negative but c is positive? This is a different twist because now we need to find out what multiplies to 3 but adds up to negative 4. How does that work? Well, you have to remember that you can multiply two negative numbers and get a positive number. So if our b is negative and our c is positive, we want to think about negative factors. Negative 3 times negative 1, that is positive 3 when you multiply it, but when you add them, it becomes negative 4. That's what we need. So the nice thing is, if b is negative and c is positive, you're just looking at all the factors being negative. So we get x minus 1 and x minus 3. Let's try this for the next one. We want to multiply to get positive 6, but add to get negative 5. So I need both my factors being negative. So negative 1 and negative 6 is one possibility, and negative 2 and negative 3 is one possibility. Which of those adds to negative 5? That would be negative 2 and negative 3. So x minus 2 times x minus 3 is the factored form. Now we want to multiply to get to negative 6. Try this one on your own. All right, did you get it? There you go. Negative 1. You notice I picked the exact same c, but my b changed, so I can list the factors again. Negative 7 is what we need, so it's negative 1 and negative 6 this time. X minus 1 and x minus 6. All right, here's a bunch of sorted practice. Go ahead and try all these on your own, and I'll show you how to do them. All right, for the first one, we multiple factors of 12 are these. What adds to 7? That would be 3 and 4. So x plus 3 and x plus 4. For the next one, we have a positive c but negative b. So we need to think of negative numbers. So negative 1 and negative 10, and negative 2 and negative 5. Which ones add to negative 7? That's these two. So x minus 2 times x minus 5. For this last one, negative 15. So we need a positive and a negative. So negative 1, positive 15, or positive 1, negative 15. But there's also 3 and negative 5, and negative 3 and 5. Which of these add to negative 14? Well, the first set adds to positive 14. So be very careful. We need negative 14. So it's the second set, x plus 1, x minus 15. Thank you very much for watching.